Hello everyone, it's time for class, so let's start today's tutorial. I'm Sulin, and the other TA, Liu Hui, and Charles are already here. And if you have any question, you can just send email or just ask questions right now. And okay, today's tutorial will conclude two parts. The first part will introduce some machine technologies to you, and the other one is will introduce some practical tips to you to help you construct your structure and submit your CAD STL file to us to print your structures. So let's start first part. Normally, we will fabricate some structures by using computer numerical control. This method is very normal in industrial fields. And this method is using automating machine tools as well as software. And so this techniques will without human intervention. So you can see this video first to have an understanding of the CNC. You can see there is a big house, and inside the house there are some machine tools, and these tools will align the structure and start to construct the structure. And this is the machine tools. They will start to deduct the materials from a bulk material, and it will start to construct a metal helmet. Yes, as we all see, the machine tools will deduct the materials from this bulk structure, and finally, it will construct a very cool helmet by using the CNC technology. So from the video, we can see the CNC is a subjective machine technology. So for the tolerance, it depends on the machine tools like drill, lathe, or mills. So normally, its resolution can be reached to 0.05 millimeter. And for the material, any material can be fabricated as long as it can be cut by the machine tools. So this is the first technology, and the other two technology is 3D printing technology. The first one is the fused deposition modeling. This technology will be the main technology we used in our project one. This project is by melting the material and fuse together before cooling down. So we can see the video to see what is FDM. As you can see, this machine is a picture of FDM, and the filament or material will be melted by this device. It will heat up the filament, and then drop the materials or liquids on the substrate, and then it will fill these materials, fills the materials together and form the structure layer by layer. So finally, it would form a structure we design. And these materials will be used for FDM. So this is the FDMs. In conclusion, the FDM is by melting the material and fuse them together before cooling down. So the resolution of FDM is mainly depend on the width of filament, that is the width of nozzles. Just in this picture, the resolution is dependent on the width of the nozzles. So normally the tolerance of FDM is 0.2 millimeter, which is a little bit larger than the CNC. But and for the material of FDM, it should be thermoplastics because the materials should be able to melt it by the devices. Yes, so mostly PLA or ABS or PETG would be used for FDM. And there is another technology as 3D printing technology to be used for fabricate structures. That is the stereolithography, also called wet photopolymerization. And we could also see another video to get to know what is the SLA. There is also a very short description of FDM. And we could see and this is the SLA. The SLA is fabricate the structure by using a beam of light to cure the polymer, and then they will form a structure. So SLA can be include two types. One type is SLA and another is masked SLA. So what are the difference between them? First, SLA conclude a wet. In the wet, there are photosensitive polymer, and by using a beam of light, it will cure on the platform. When complete one layer, the platform will increase up, and then again a beam of light will irradiate on this platform. So the structure will be constructed layer by layer. But for MFLA, that is mask stereolithography, it only takes one time to fabricate one layer of structure. That is by using a mask, and then by using the light irradiate on the mask, it can construct one layer of structure immediately. So the resolution of the MFLA, it depends on the resolution of LCD. And for the SLA resolution, we can see the video, it can reach 0.01 millimeter, which is smaller than the FDM. So right now we have already get to know 3 technologies about how to fabricate the structures. So let's compare them. Why should the 3D printing appears? That is, there are some challenges when we use CNC to fabricate some structures. The first is that when we need to fabricate some structure with undercutting a hollow structure, we cannot use CNC. Why? Because in this video, we can see we need to use the machine tools, insert or touch the structures and deductive some materials from the this bulk material. So in order to fabricate this structure, because it's very difficult for us to insert our machine tools inside the material to deduct some materials, right? So this is one problem when we use CNC to fabricate some complicated structures. And then for the tolerance, we can have FDM and SLA to meet the requirement of our project. So nowadays, normally we would like to use 3D printing to fabricate most of the structures. And for the materials, mostly for CNC, we would like to use metal because in this scenario, the metal would not deform when we use machine tools to deduct the materials from the metals. And right now, we have described 3 technologies. And also, sometimes we need to face some challenges when we use 3D printing. One example is that some students would ask, we found some model online and doubt whether these complicated structures and some tiny edge can be printed and assembled in the real life. We could see this example maybe for CNC technology because there are some very tiny edge and the resolution might be very fine. So we could not just use this model directly to, we cannot directly fabricate this structure by using 3D printing because there is also some limitation of 3D printing. One example is that when we use the FDM, the tolerance of FDM is just 0.2. But when we design a structure for CNC, we could only consider the toleration of CNC is 0.05 millimeter. So when we use another technology, it cannot meet our requirements, so it would have some problems. And then I will give you some practical tips when you design your structures. The first is to how to change your SolidWorks files to STL, and then we could help you to print your parts. The first one is when you complete a structure in SolidWorks, then you should save as a STL file and then send to us. But when you change save STL types, you should select options. And then in the resolution types, you should set file is okay. So then click OK and save. And then you could have the STL file for this structure. And then you could just send me right now to this step is okay. And then we will use your STL file to slice structure by using this software. And then the STL file will be changed to G code. This is a code for 3D printing code. And then the printer will use this code to print your parts. And when you design your structure, there are also some tips you need to consider. The first is that you cannot design a thin film less than 1 millimeter, because if you design so thinner, it cannot be printed successfully. So I would suggest you print width larger than 3 millimeter. It would be standard and it will not be easily break down. And another one is the tolerance. For example, if you design a 10 millimeter hole and you also want a pack can insert into the hole, you cannot just set their diameter are all 10 millimeter, because in this case, the pack cannot insert into the hole. Just like this, if you print a hole with 10 millimeter, and also this pad has a 10 millimeter diameter. So in this case, we can insert because they are all 10 millimeter. And if you want a normal fit between FDM parts, you should design a pad with just like 9.7 millimeter. And then you could have a normal fit between these two parts. So remember these important tips. You will not make the same mistakes. And another tips is that support. Yes, we could see this structure. If you send the structure just like in this direction, you will receive a structure with many supports just in this area, because the FDM technology will construct the structure by fuse the materials together layer by layer. So in order to fill this suspend part, they have to add some support to support this suspend part. So after printing this structure, you need to consider how to remove the support from this structure, it would be very difficult for you to do the post. So in order to make your work more easier, you could just rotate this structure 90 degrees, just like this. And then if you use FDM technology, construct the structure layer by layer, there is no need to add any support to in your structure. And then you could have a smooth structure. Oh, and another tips is about the support. In some case, you would want to build a structure with a hollow or just undercut tortuous slides inside the structure, but you, as said above, they cannot build a hollow structure without the support. So inside the structure, they will be very so much support inside the structure, and you need to consider how to remove the support inside the materials. It will be very difficult. So in some case, there would provide water soluble support in the structure. So when you immerse the printed structure, and then the support can be removed by water. But in this case, in this project, we will not provide water soluble support. So you need to consider how to design your structure, and you will not face the challenge by you removing this support. Yes. And this is the final tips about the strength. As we said above, we construct the structure layer by layer. So if you want the we construct the structure layer by layer, so the adhesion between layer by layer will not be standard than the direction, the vertical direction. That is, the vertical direction can take out less shear strength because layers are not as close fused as in horizontal direction. So if you want stand much strength in one direction, you should set the your structure. You should set the structure in the vertical direction. In this direction, you can let your structure face the larger strength. Otherwise, it would be failure when you apply a major strength along the horizontal direction. Just like this picture, if you apply a strength along the horizontal direction, it might be failure because the adhesion between layer and layers would be very weak. So I will also show you a video to show you how to remove the support, because this problem you might face in the following printing process.
Today, standard supports for sometimes when you're slicing something, you're slicing software, in this case, it is process slicing 2.3.0 data version, hopefully the right corners so that you can check that as well. And these are my supports that I have. These are standard supports. You can also use some different kind of supports, free supports, and custom supports, because in the rules of 3D printing, you can write something in the air. Meaning you can do some bridges, not that's wide, and also when your muscle is moving else. If that happens, you are going to get some noodles, some spaghetti, and you want. So in that case, support is needed if some angle of the piece is reached. So there are 20 seconds for right supports that will be respectively. So sometimes it also happens that you don't need these supports. Well, then you are very lucky, and then you have less work to do. But in this case, I am going to remove some supports. There are some tools that you are going to need if you are going to remove supports from your model. One is the pliers. This is the plier that where you can cut this cross very easily with. But you can also use after that some files. You got straight points, you got some triangle versions, round versions, different kind of ones, just to make sure that you support the as possible. And that when everything is removed, that you can clean it up. Also, one thing that you can use is a spatula. I don't recommend to use this as a support remover. However, it can be handy, but I don't recommend it. When using a glass pad, don't use a spatula to print that. It will ruin it and then have. So what I do, well, it's not really a tool, it's just some material. When you are removing something that is a part of the mural, use some power glue to glue it together. Just use brush it, and also when you're going to use glue or super glue, use it until you are finished, and please don't throw away your broken parts. That being said, let's get this on to the printer, and then so in this case, I'm using a glass pack, and 3D printer is full of more than enough. I'm going to remove the first line, put in the printer up, and just like that. It's very easy to remove. It's going to be very silent now because the 3D printer was printing for a very long time for the only robot there. And for this kind of content, it was this kind of thing that everything is printed, but now that also means that my search live stream is closed for the moment, but as soon as I'm going to print 3D print other things, then that's really super. So now Picture is to ensure that you work with the tools too much support going around with the so as much as possible with hands. Small parts you can always remove the wires that you have to the okay, with nose, and leaving this part there. And try to remove as much as possible.
And yes, finally, by removing the supports, you would have a very smooth structure. But many times, by using 3D printing, you have to spend many times to remove the supports. So this is a process you have to face. So in order to decrease the time to do this, you should consider much about the design when you using SolidWorks to design your structure, just like eliminating the process by just let your structure facing in this direction, or just eliminating the chance you would need to design a hollow structure like this. So this is some tips I would recommend to you, and that's some tips. And finally, do remember the first deadline to submit your STL file is before October 3rd. And then you will receive your printed parts in October 5 or 8. And do remember to register your SID or your name in lab sections form. And then you can come to the lab to finish your structure. And also you have the second chance to print your structure. This is the deadline. And finally, when you finish your project one structures, you have to do a presentation and also need to hand in a project report and video clip. And the project report, you have to hand in your own report individually. So just remember this. And this is a take-home message. You can take a picture. And this is all the today's tutorial. Do you have any question? And also one thing is that when you design a structure, there might be many parts and you need to assemble them in SolidWorks to make sure their position or tolerance are correct. But do not hand in the assemble files into the Blackboard because we can just print one part one by one. If you just hand in the assemble file, it may have some problems when they are printing. So you need to hand in the part file, not just the assemble file. So if you have no questions, you can just leave the class.